Algebra 2, Concept 2 notes, parent functions, and transformations. And this is part 2. We're going to go through a lot of information quickly, so you may need to frequently pause the video to get all the information down in the table. So now we're going to look at equations of linear absolute value and quadratic functions and what we can do to those parent equations to create transformations. So if you look at the top of the chart, you'll see y equals a times the general function x minus h plus k. So those variables a, h, and k, those are actually constants, number values that we can introduce to create transformations with our equation. When they're in that location, that would be a situation where we would have what we call a vertical stretch or shrink. Now, if you look at the equation just next to it, it looks virtually the same, except notice the a value is multiplying in by the input. When that occurs, we have what's called a horizontal stretch and shrink, which we're going to talk more about later on in the notes. All right, so let's start. So we're going to talk about, in general, y equals f of x. So that's just the general form, meaning any function. And then I said specifically we'll be addressing linear absolute value and quadratic. So in this table, we'll show each type of transformation. Notice I have a description. So in this first part, we're going to talk about horizontal and vertical translations. Slides is what we call them, left, right, up, or down. So with the horizontal translation, a value in the h position is added or subtracted. For a vertical translation, a value k is added or subtracted at the end of the function, or to the entire output. So let's start with the parent linear function f of x equals x. We're going to shift a different linear function 2 to the left. The linear function we're going to work with has already been shifted, so it's x plus 2. We're going to shift that 2 to the left. So if you look all the way over to the left in this row, you'll see if we shift to the left, we need to add an h value. If you look up above, we'll see that the h values get added right into the input. So I'm going to call my new function g of x. I'm going to open a parentheses and show that I am adding 2 to the input. So I'm shifting it to the left. Now I'm just going to simplify. So I'm going to drop those parentheses and combine my 2's. So my final linear equation from f of x equals x plus 2 that has been shifted 2 to the left is g of x equals x plus 4. Let's try an absolute value. So there's the parent function. And then here's the absolute value equation we're going to be working with. And we're going to shift it 2 to the right. So f of x equals the absolute value of x plus 3. To shift that to the right, we need to subtract 2 to the input. So right in there by the x. We can simplify, so that will become x plus 1. So our final equation of our function shifted 2 to the right is g of x equals the absolute value of x plus 1. Now let's look at a quadratic example. So here's the parent. We're going to shift this one 3 to the left. Here's the quadratic function that we're going to start with. So to shift it 3 to the left, I open up a parentheses around the x because I just need to add 3 to the input. And then I'm just going to rewrite that. Actually, I'm not even going to rewrite that. That will be it in its final form. So now let's talk about vertical translations up or down. So if you look down in the next row all the way over to the left, you'll see that I have put brackets or braces around the directions. If you want to shift a function up, you're going to add a k value at the end. If you want to shift it down, you're going to subtract. So we're going to start with that same linear function, f of x equals x plus 2. We're going to shift it 3 down. So we're going to do that by subtracting 3 at the end of the function. And then we'll simplify. So g of x equals x minus 1. Now for an absolute value, we're going to shift this one 3 up. We're going to start with that same absolute value of x plus 3, we just need to add the 3 to the entire output, or another way to think of it is at the end of the function. And we don't need to simplify it all. That will be our final function there. For quadratic, we're going to shift 4 down. And we're going to start with f of x equals x squared plus 2 again. So you're probably getting the hang of this. To shift it 4 down, you need to subtract. This may be a review for you from Algebra 1, just depending on where you got. All right, so just before we leave this, if you want to do a horizontal translation, so a shift left or right, remember it's a value that is either added or subtracted right into the input. And it's opposite of what you would think. Shifting left, you're going to add. Shifting right, you're going to subtract. For a vertical translation, you're going to add or subtract a value at the end of the function or to the entire output, and we call that a k value. Now let's talk about 2 other types of transformations. These are reflections. We can either have a y-axis reflection or an x-axis. For a y-axis reflection, the input only is made the opposite sign. For x-axis, the entire output is made opposite. So let's start with a linear function. We're going to do that same linear function we've been working with, f of x equals x plus 2. Now our translated one will be a reflection in the y-axis. So notice I only multiply the input by -1, the x value. So our final function is g of x equals -x plus 2. Let's look at that absolute value function of absolute value of x plus 3. So I need to multiply just the input by -1. So that will become absolute value of -x plus 3. And then finally, our quadratic, f of x equals x squared plus 2. So I'm going to open a parentheses and put that -1 multiplier by the x. But look what happens when I simplify. -1 squared is +1. So a y-axis reflection will look the same as you'll end up with a graph that looks like the original graph in a quadratic. Now let's talk about reflecting over the x-axis. So we're going to start with that same linear function, f of x equals x plus 2. And now we need to multiply the entire output by -1. We need to switch the sign. So we get -x minus 2. With our absolute value as well, and I'm going to notice that I'm writing in green. There, let's make it purple. So f of x equals the absolute value of x plus 3. I need to multiply the entire output by -1. Here's an important thing. When we multiply an absolute value expression, we do not multiply into the absolute value. We just have to put that multiplier out front. And now with our quadratic, we have f of x equals x squared plus 2. We're going to multiply all of that by -1. So it's just -x squared minus 2. So before we leave this, when we reflect in the y-axis, it's the input only that's multiplied by -1. A reflection in the x-axis, the entire output, everything on the right side of the equal sign is multiplied by -1. All right, now we are to stretches and shrinks, or compress. That's another word for it. So a vertical stretch and a horizontal stretch. A vertical stretch has a y-axis orientation, meaning that it's going to stretch the graph towards the y-axis, or if you do a shrink or a compress, it's going to shrink away from the y-axis. With the horizontal stretch and compress or shrink, it has an x-axis orientation. So from the original graph, a horizontal stretch will stretch it towards the x-axis. A horizontal shrink will shrink it away from the x-axis. So those are good ways to think of that. Now let's look back up at the top, vertical stretch or shrink. To do that, the entire output will be multiplied by a value. So if we want to stretch, then the absolute value of our multiplier will be greater than 1. If we want to compress or a shrink, the absolute value of our multiplier will be less than 1. So let's start with a linear example, and I think I'm going to use the same equation, x plus 2. Yes, and so I am going to do a stretch because my multiplier is greater than 1, and this is a vertical stretch. Notice I have to multiply the entire output, so both the x and the 2. So vertical stretch is g of x equals 2x plus 4. For my absolute value, f of x equals the absolute value of x plus 3. Now I'm going to create a vertical shrink or compress. So that absolute value gets multiplied by a half, and that's all I can do is just sit it out front. When we talk about stretches or shrinks, we use, because it's a factor, a multiplier, we use that number. So we're going to call this a shrink by a half. Notice I went back and added a stretch by 2. Now let's look at a quadratic, and we're going to use a little more interesting equation. So x plus 2 squared minus 3. We're going to create a vertical stretch by 3. So I need to multiply all parts of that quadratic by 3. So I get 3 times the quantity x plus 2 squared minus 9. That is a stretch by 3. Now let's talk about horizontal stretches and shrinks. So something interesting happens with the multiplier if you look in that second column. So the input only is multiplied. If I want a horizontal stretch, my multiplier will actually be less than 1. If I want a shrink or a compress, my multiplier will be greater than 1. So it's opposite of what you would think. So let's look at this linear example. And we're going to start by doing a horizontal stretch. So that means our multiplier, it's a stretch by 2. So my multiplier will be the reciprocal of it, 1/2. So this is a horizontal stretch by 2. Notice only the input was multiplied, and it's multiplied by the reciprocal of that stretch factor, which is 2, multiplied by 1/2. I know, a little tricky. So let's start with our absolute value of x plus 3. Now we're going to do a horizontal shrink by 1/2. So our multiplier will be the reciprocal of that, 2, only the x value. So for a horizontal shrink, it will be g of x equals the absolute value of 2x plus 3. That's just the nature of horizontal stretches and shrinks. So now let's start with x plus 2 quantity squared minus 3. And I think we're going to do, yes, another horizontal stretch by 2. So our multiplier is a half. Notice only the x gets multiplied by a half, and that is just how we write our final quadratic equation. All right, this concludes part 2 of our parent function and transformation note.